Incidentally, the term wormhole didn't pop up until physicists Charles Meissner and John Archibald Wheeler coined the term in a paper they wrote in 1957. And Wheeler was inspired by work back in the 1920s by Hermann Weyl that was not focused on gravity or matter, but rather making one-dimensional tubes from electromagnetic field energy. It wasn't related to black holes, and indeed the term black hole was also coined by Wheeler about a decade after the wormhole. So while wormhole explanations nowadays tend to lean heavily on black holes in discussion, for the first decade we discussed wormholes, black holes were never even mentioned by name. Half a century before that, we get our first formal example of one described under theoretical physics and math from Carl Schwarzschild in 1960, and what he described is basically a black hole. Indeed, the event horizons of black holes have a radius based on his calculation called the Schwarzschild radius. These types of wormholes, named after him, are prone to collapsing if any matter passes through them and would require some form of exotic matter like negative matter to hold them open, otherwise even a beam of light going into one would collapse it. And of course, even in the most empty part of the universe, particles of light from the cosmic microwave background radiation are constantly passing through, so we would not expect these to stick around anywhere naturally. Nowadays, anyway, they could potentially exist at the end of time when the CMB radiation was effectively gone. However, later analysis indicated that we could maybe potentially make small ones that would not be collapsed by a very tiny trickle of electrically charged particles, which would hypothetically let you use these for faster-than-light communication, emphasis on maybe.